So what we talked about last time in 7.8 is for a set of data, finding a regression model, right? And trying different things out, trying the different functions out, whether it's a quadratic, whether it's just a line, a linear model, whether it's exponential or logarithmic. So let's look at one more example on that. So we've got a real set of data here. So most of the problems that we've been looking at, and most of the ones I gave you, for instance, they're kind of not real. The nice thing about our AP Stats book, for instance, is that almost all the problems come out of real studies in medicine and stuff. So I think this was out of a pediatrics journal. So what is this talking about? Let me see what it said.
Calories.
So it said lunchtime. Does how long children remain at lunch at the lunch table help predict how much they eat? The table gives data on 20 toddlers, this is only toddlers, observed over several months at a nursery. Time is the average number of minutes they spent at the table, okay? And calories is the average number of calories that they consumed. Yeah, so our idea is to create a model for that data and then use it maybe to make some predictions. So I'll make up something to predict something, okay? So that's the situation. So let's get that in our calculator. So go ahead and put that in list 1 and list 2 on your calculator. Let's see if we can find a model for it, okay? I will go over it. So let's see. Anything else? No. Note, one thing they said, does how long the children remain at lunch help predict how much they'll eat? That tells you what X and what Y are. So they said this, does time spent help predict how much or how many calories are consumed? So I think that tells us something important right there. That means they're saying what is X and what is Y in this situation, because it could be either way. And most of the time it doesn't matter a whole bunch, but they asked a specific question. They said, does time allow you to predict calories? So what's X then? Time. They're asking, does time drive calories? Does that make sense? It could be the other way around, and sometimes it really doesn't matter a whole bunch. Most of your problems, you're not going to have to worry about it too much, but like in higher level stuff, you have to be aware of what variable is driving or affecting what other variable, and they asked a very specific question here. So you're going to want to put what in list 1? The red or the black values?
The red.
The red values are going to go in list 1, and the black values are going to go in list 2, so be careful if you've already started that. Okay? Darn it, that's so sneaky, right? So you can swap them if you know how to do stuff better. Yeah. Should I?
Yeah.
Okay, let's mess around with our list a little bit. Do it either way. Okay, so I'm going to enter stuff, and I'll erase this for you people watching the video and stuff. So I'm going to put them in my lists. So I'm going to clear out my lists. And I guess I'll just pretend we ignored this, and I'll just put the black things in list 1. So I'll just go 472. Yeah, I have to. I highly advise you be careful though. So it'd be a lot easier if you did this the right way and just switch the lists right away. But it's good to learn this too. Stats for next year. Okay, then I'll put my red guys in. I'm going to use them. Okay, looks like my lists are the same size. So I'm probably okay. Now I'm going to erase this so we can see better. Okay. Okay, so if you had it flip-flopped, you're ready to graph, zoom stat, and all that stuff. Okay? But right now I have my axes flip-flopped. So if you ever want to use a different orientation on that, you just go to where you turn your plots on. You go to second y equals. And my plot's off anyway, so I needed to turn it back on, yeah? So I'm going to turn it back on. It's still on scatter plot, and here's where you fix it. See how it says X list and it says list 1 and Y list is list 2? What did we want to do?
Switch it.
We wanted to switch it. Now, I will caution you heavily. If you switch this, what are you going to have to do next time? Come back and switch it back. Otherwise, is it going to catch that for you? No, and you're going to do all the rest of them wrong. So that's why I'm saying heavy caution here, yeah? So I'm going to put list 2. To get list 2, notice you hit second 2. If you see it there on your calculator. And I'm going to go list 1. And then I'm going to hit graph. Nothing showed up. Oh, I've got a curve. I better go delete that curve, right? Couple curves. So I'm going to clear out my y equals stuff. Try it again. Oh, it still didn't work. Why not? The window's messed up. So I go zoom. Number 9. Ah, there's my scatter plot of time spent at the table in calories. Okay? It's because something's wrong. One little thing's off, so you gotta listen carefully. Okay, so we should have a scatter plot to look something like this, yeah? Okay, so there's our scatter plot.
Lovely.
So we're supposed to basically create a model from that scatter plot. So what do you guys think? Does that look like it's linear? Does it look like it's curved, exponential, what?
It looks like it's like the last few seasons,
Remember, like 1 or 2 points don't determine a pattern. You're looking at the overall trend. Doesn't it look like this?
Yeah.
I think it looks pretty straight. I don't see any evidence of curvature, so I'm going to do linear regression. If I did see curvature, I'd have to try quadratic or one of those other things, yeah? And then I'd have to start comparing the r-squared values as well. So looks like we're going to pick linear. I don't think this is curved. So pretty straightforward on this one. What do you guys think also? Do you think that this is strong enough to like actually use in the real world? Real world data is never perfect. This is very strong actually. It's quite good enough. It's not super strong association. It's moderate, maybe even high moderate, which means it's plenty good for us to do stuff with, okay? So let's go and calculate the model. So where do we go to do that? Stat. And then if you can't see on the movie, it's over on top. Calculate. We said we wanted a linear model. So we run it. Ooh, one thing that's you got to be careful about here too. You know how I had it switched?
Yes, it's back now.
I have to tell it the right order. When you just hit enter, it says list 1, list 2. What did we want?
List 2.
Oh gosh, dang it. See, that's why it's dangerous doing it that way, but good to learn about. So I'm going to clear that and do it again. Stat, calculate. I'm going to see if I can bring this down for the video. It's good to think about, because in stats and AP stats and in college classes, you just switch your lists around, so you should be aware of that. So close, okay. So I'm going to try it again. Go linear regression. And by the way, would you know it's messed up? You could know it's messed up. I'll show you how to check. We'll check ourselves, okay? So up there, I'm going to say list 2. This says list 2, comma, comma, list 1. There's our model. So we're going to write it down. So y equals to what?
Mine's a little bit off.
Probably just have a number slightly off.
550 instead of 560 and make it 2 instead of making 3.
Okay, so it looks like this.
Mine's still not like yours at all. My numbers are different than yours.
A little bit.
A little bit.
Might have just entered something wrong, or maybe I did.
You want us to just use your numbers?
Whatever. Right, use your own numbers. Okay, so I got r squared is 0.421. That's not quite as good as I was hoping for. It's not awesome, but it's not terrible. Okay, so how can I check to make sure that I did this right and I didn't switch my list or do something wrong? Go type your model in. Put your model in y equals and it better fit that like it was supposed to. So I'm going to type it in. What do you guys think? Did I have it mixed up or messed up, or? It looks right. If we'd have done it that other way, what would have happened? Probably. I bet it would have been something like that, or something that was off. You know what I mean? So you could catch yourself that way. Anyway, so I've got what I need. I think that in my explanation link on your worksheet, I'd say what r squared meant. So in our model, 42% of the variation in calories can be explained by the variation in times. That's not great. 42% isn't awesome. Anything over 50% would be really good. I'm not feeling great about this model, but it's not worthless either. It's kind of in the middle, you know?
Wait, so how do you get the line through it afterwards?
I just went to y equals and I typed in what the model that we calculated. I typed it in. Okay? You can always do that. Okay. So there's that one. Let's make a prediction. What if it said predict Okay, so 2 questions. The whole point of doing this was to answer these questions, yeah? So, predict the calories for a toddler who spent 20 minutes messing around at the table and eating. So how will we do that? I said 30 minutes. So for 30 minutes, I'm just going to plug in, right? We just say, well then, we predict y equals, we just plug it in. And then use your calculator, and what do you get for that? What is that? I guess I could do it on the screen too. Make sure you get your units on there, right? Those are calories. So that's what our model predicted for that specific type of toddler. For that toddler, I mean. I guess it's not a type of toddler. So there's that one. Remember, if you have this in your calculator does things lickety-split much faster than this. If you've already gone to the trouble of putting it in Y1, There's all kinds of ways to do things quickly on your calculator. Like let's say it said make 5 predictions. Would you want to type this in every time? No. Our goal for the ACT and for all kinds of other reasons is to be able to do this quickly. So here's how you can do it quickly. It's in Y1. Go grab Y1 and plug it in like a function. Y1 is if you go to variables, hit vars. Vars is over here. You don't have to do it this way, but it sure is nice. So you hit vars, it brings you here. What are we working with again? What kind of stuff? Statistics stuff. Well, actually, I just want the function. We are looking at statistics stuff. So notice, like the regression equation is stored here. You might mess around with this menu too, but I actually want something else. So I'm going to try it again. I'm going to go vars, yvars, function, and there's y1. If you hit y1 and you just say parenthesis, plug in what we want to plug in, 30, it just takes it and plugs it into your thing. So now if it came along and it said predict someone who spent 50 minutes, you just say second entry, and you'd scroll over and say for a 50-minute toddler, 406 calories. How about for a toddler that spent 23 minutes? Looks like that's 489 calories. You see how fast this is? It's a very useful thing for a lot of things, okay? Not just this topic we're doing now. Anyway, so that's a nice thing to know. How about part B? How about predict the calories for an adult who spent 10 minutes? Comments on that? Okay, let's see some hands.
It's not adults, it's for toddlers.
Ah, excellent. So, can we do this legally, legitimately? The model, all the data we have that we created our model with came from who?
Children.
Toddlers. So for this reason, that would be like not allowed, right? Our model does not fit adults. What else is wrong with that? Something else wrong with it too. It's outside of the what? Lots of ways to say it. You can come up with another word that works.
Oh, extrapolation.
Yeah, this is extrapolation because it's outside the prediction range. Do we have any values that are like 10? Anywhere close to 10 there? Like our scatter plot really started like where? About 20, like around the 20 range. We don't know anything about what's happening over here. Those toddlers who eat really fast, maybe they totally changed the model and now the model goes like this. Let's say that those toddlers who eat really fast, they all like start to curve down or something. Maybe it starts to curve and the line doesn't apply anymore. We don't know. Okay? So that's extrapolation. So there's 2 reasons we couldn't answer B. So if you did answer it, I mean, that's pretty bad. Okay. Okay. There's another example.